So apparently, you guys are scared of number 2. Why are you scared? Okay, so step 1 is to make the bases the same. All right. Now, first of all, we all know that this is a fraction, and this is not a fraction. So that's problem number 1. All right. You don't want this to be a fraction. So you're gonna have to take this 64 and move it up. And that would make it 64 to the negative 1 power. Or you could already try to change both to be the same base down here and then move it up later. So you could change this to a 2 to the 3rd, and you could change this to a 2 to the 6th. But that's kind of pointless. I mean, you could do that if you want. There's many roads to the same place. But this is 8, and we know that 8 squared is 64, right? So you might as well change the 64 to an 8. So let's start by doing that. Let me take this 64 and make it an 8 squared. Yeah? Now, instead of leaving it down there because I don't want it to be a fraction, I want to take this 8 squared and I'm going to move it up, and it's going to become 8 to the negative 2 inside the parentheses over 1. Okay, so that's really ugly right there, but I hope you understand that this is what it ends up looking like. I want to put 8 to the negative 2 power. I said negative 1, sorry, it's negative 2. So 1 over 64 truly is 8 to the negative 2 power. You guys agree with that? Okay, so we have the base 8, and we still have the outside exponent, which is 0.5x minus 3. And we have the equal sign, and on the other side, we also have base 8, and we have 9x minus 2. So yeah, you could have changed them both to base 2, but if you could both change them to base 8, it's actually easier for you. Because right here at this point, you're already able to cancel out the 8's, and your new equation will actually be negative 2 times 0.5x minus 3. So how about this? If you want to cancel out the 8's, go for it. Cancel them out. And let me rewrite this. Negative 2, but it's going to be times 0.5x minus 3 equals, and on the right side, you don't even have to do anything, just 9x minus 2. Okay, so I'm showing my work here. I know some of us would already distribute here and just write down the answer. I'm showing my work. So let me distribute negative 2 times 0.5. That's going to be negative 1 with an x. Negative 2 times negative 3 is positive 6. Equals, bring down the 9x minus 2. And continuing to solve, let me move the x's to one side and the numbers to the other. I'm going to move the negative 1x by adding 1x. So on the right side, I'll get 10x. And I'm also going to do 2 steps in one here. I'm going to move the 2 over by adding 2 and adding 2. And I get 8 on this side. So I have 8 equals 10x. I need to get x by itself. I'm going to divide by 10 and divide by 10, which means that my final answer, reduced, will be 2/5. So x equals 4/5. Sorry, reduces down to 4/5. 8/10 reduces down to 4/5. And that's your answer. So on all these, on the first part, the trick is to be able to look at both bases and see how you could get them to become the same thing. All right, so you could have done this one to be 2 to the 3rd. You could have changed this one to be 2 to the 6th and then moved it up. But 8's easier. There's less work to do. So on all these, it's just a question of manipulating the base. Like right here, this is going to become what? What base are you going to turn this into? You can't leave it 1/2. It's a fraction. What base are you going to turn this into? 2 to the negative 1 power. That way, you're able to move it up and it's no longer a fraction. Over here, you're going to change this to a 2 to the 4th power, right? Let's not do it, though. I just wanted to go with you right now to show you that you need to it's just a question of getting the same base. Like right here, guys, what am I going to change this fraction to become, like inside?
4 to the negative
4 to the negative 1, that'll work. Only because 64 could also be changed to 4 to the third power, right? I mean, you could also go 2 to the negative 2, so this could be 2 to the negative 2, and you could change this to 2 to the 6th, but 4 actually makes it a little easier for you. So the question is just, are you able to look at both bases and change them both? Again, might as well just write this one down. 4 to the negative 1 is what that one would be. And the 64 right here, we're going to change that to a 4 to the third. And of course, you guys should be able to continue on from there, distributing the exponents, canceling out the bases, writing your new equation, and solving. Okay? Or another option that you could have done is you could have changed the 1/4, you could have changed it to be 2 to the negative 2. And then you'd have the 2x plus 2 equals, and you could have changed the 64 to be 2 to the positive 6 to the x minus 1. I'm just showing you different options here. I'm not even solving the whole thing. Okay? So you could have also gone this route, changed them both to base 2, but changing the base 4 is a little easier because it's easier to distribute the negative 1 and the 3 instead of negative 2 and 6. It's up to you. You're going to get the same answer anyway. Okay, so this is an option up here, a different option. It's up to you guys. Sometimes there is no option. Sometimes you could only change it to base 2. Sometimes you could only change it to base 4. Anyways, I think we have the idea on how to solve. You could also look at yesterday's videos that have more examples of those. Let's jump to writing equations, exponential growth or decay equations, given 2 points. Now let's go probably to the most confusing one, like number 10 right here. Okay, so let's think about this. If I had a graph, and I was at the coordinate 0, negative 0.2, that's hardly anything. That's pretty close to 0 itself. 0, negative 0.2 is right there. And then if I go negative 3, I'm at negative 3.125. So what's happening? From left to right, it's decaying. So you should be able to logically see these coordinates and see that it's going to be a decay function. Okay, once again, this first coordinate 0, negative 0.2 is right there, really close to the origin. And the other one, negative 3, negative 3.125 is right there. So you see that it's decaying from left to right to nothing. So we know it's a decay function. You don't need to do this, by the way, guys. This is just extra understanding, right? Let's actually get to the writing equations part. In order for you to write an equation that's exponential growth or decay, you need to know what it looks like. It looks like this. Y equals A times B to the x power, assuming that there is no h or k. So we need an A value and a B value to be able to write the equation in exponential form. Okay? So let's use our first coordinate, which is a x value here and a y value here, to plug it in. Plug in the 0 for x right into the x, the y, the negative 0.2 for y right here, and then you'll be able to cancel out the b's and find a. Let me show you what I'm talking about here. Instead of y equals, I'm going to write negative 0.2 equals. A, I don't know what A is, so I write down A. B, I don't know what B is, I write down B. To the x power. X, in this case, is 0 when I plug in this coordinate. This y went into the y spot, this x went into the x spot. And we all know that b to the 0 cancels out because b to the 0 is 1. Anything to the 0 power is 1. So I really have, if you look at this thing, the a value. I have half of what I need. I know that a equals negative 0.2, or you could even say negative 2/10 if you read it as a fraction. Either one's good. As a matter of fact, I think the worksheet will leave it as a decimal. I don't know. But let's keep going here. If you know that a is negative 2/10, that means that you could plug it in. You could plug in negative 2/10 for the a spot. Now, we already used this x and this y, so now let's jump to this x and this y and plug in the x and the y, and we already know the a, so we could find b. So instead of y, I'm going to write negative 3.125, and equals, instead of a, I could write down negative 0.2 or negative 2/10, whatever you guys want. You guys want to keep it a decimal? Yes. Okay. Negative 0.2, and then times b to the x power. What's the x power? Negative 3 in this case. All right. So now let's solve this thing. Well, first of all, we could move the decimal. Actually, let's divide by 0.2, negative 0.2. That way we could get the b by itself. So let's divide this side by negative 0.2. Instead of struggling, let's just use a calculator, right? Go for it. Tell me what we get. We're going to end up with b to the third, actually b to the negative third, because the x is negative 3, equals, and what's that decimal value on the left side? It's going to be positive. Negative divided by negative is a positive. Okay, say again. 15.625. You guys agree? Yay? Okay, so now I want to get rid of the exponent negative 3. So one way of doing that would be to do the power of negative 1/3. Why? Because a power to a power you multiply, and negative 3 times negative 1/3, that'll cancel out and it'll just give you b, right? B to the 1 power. So of course what you do to one side, you're going to do to the other side, negative 1/3 over here. And calculator's a good friend of yours right now. So after typing all this in with the calculator, I'm talking about hitting the parenthesis button, 15.625, close parenthesis, the caret button. In parentheses, I typed in a negative 1 divided by 3. And I hit equal, and I got 2/5 as an answer. 2/5 as an answer. Or 4/10, which would be 0.4. So 2/5 is your b value. Or 4/10. So it could also be 0.4. So I don't know if they wrote it as decimals or as fractions. I'm going to write it as fractions. Your exponential decay or growth function will be y equals negative 2/10, or you could even say 1/5, because it reduces down to 1/5. That's your a value, times your b value. Your b value is 2/5 to the power of x. So this is your exponential decay function. I said growth. Decay. Decay because the base is less than 1.